Welcome everyone to a short video tutorial on calculating theoretical and percent yield. Take a moment right now and read this question. Maybe even pause the video and go through it carefully so you can see what the question is asking. Let's start off with question A. There's a new term here, theoretical yield. So it's asking for the theoretical yield of the product. Well, theoretical yield, even though it's a new term, it's just doing what we've already been doing in stoichiometry. Theoretical yield means calculating the amount of product that should be produced based upon the balanced chemical equation. So let's go through part A because it is the same stoichiometry that we've been doing already. A good practice right now would actually be to pause the video and try to calculate how much mass of ammonium sulfate should be produced if you start with 3.4 grams of ammonia. Okay, let's review the steps. Our first step, of course, is to make sure the equation is balanced, and it is. Our second step is to take the mass of the reactant, 3.4 grams of ammonia, and convert that into moles. 3.4 grams of ammonia is 0.2 moles of ammonia. Next step is we use the ratio in the balanced chemical equation to go from the moles of ammonia to the moles of ammonium sulfate. For every 2 moles of ammonia which reacts, we produce 1 mole of ammonium sulfate. So recall, we take the mole amount that we're given, multiply it by the ratio that relates those two substances in the balanced chemical equation. This is an example of one that you might be able to do by inspection, just realizing that you just need to divide by 2. But what you're doing mathematically is always multiplying and dividing by this ratio right here. So if we react 0.2 moles of ammonia, we produce 0.1 moles of ammonium sulfate. Now let's convert that back to a mass. So the balanced chemical equation tells us that if we react 3.4 grams of ammonia, we should produce 13.21 grams of ammonium sulfate. This is the theoretical yield. Now that we've calculated the theoretical yield, let's find out the percentage yield. Question B gives us another mass of the product. This mass here is the actual yield. Theoretical yield is what should be produced on paper. The actual yield is the amount that experimentally we actually collect. Okay, so we know this is the actual yield. We see these keywords like is collected here. We also notice that typically the actual yield is going to be less than the theoretical yield as well. So that's another clue. So our equation for percent yield is the actual yield divided by the theoretical yield, and we multiply it by 100% to express our answer as a percentage. Remember, a percentage is always just the part divided by the whole. So a theoretical yield is the maximum we should be able to get. The actual yield is a part of that. So let's substitute our actual numbers in. So the percentage yield in this question is 78.7%, meaning that we obtain only 78.7% of the products that the balanced chemical equation predicts that we should be able to obtain.